Today we are going to discuss specifically about pair plot, where we are having the correlation. If you want to find a correlation between just two columns, and how we can find the correlation between them, if they are correlated or not, if they are, how much correlated they are, but just for a pair of two. Okay, so let's jump into it and I'll see you on the other side. So we have discussed a lot of things about exploratory data analysis for this particular data set only. Okay, same thing you can apply it on another data set as well. So now I'm going to tell you about a pair plot. What is pair plot? Earlier we are working on joint plot, where we are taking multiple columns at a time, two columns at a time, and we are plotting the graph from it, like we have done on this joint plot x and y. In x we are having age, in y we are having max HR. This is the distribution of age, this is the distribution of uh, max HR, maximum heart rate. Okay, but this is something we have seen from the correlation, that they are having maximum correlated. So let's plot the graph from it and let's see if the regulation line fits or not, and it is fitting. But how we can plot all the graphs, all the possible combinations? For that purpose, we are having something called as a pair plot. How to work on pair plot? So pair plot SNS dot pair plot, and inside that I need to pass my data frame where the whole data lies. Okay, once I'm having the data frame, we need to execute the code. Okay, the problem with this is, if we are having multiple columns like 50, 60, 80, 100, 1000, so then it might run out of the memory, because it is going through each and every combination and plotting the graphs for it. Okay, so now if I'm so it is same like the correlation. Like here we can see, the in the correlation we are having the graph between age and age. So this is here, age and resting BP, this is here, age and cholesterol, this is here, cholesterol and age, this is there. Okay, here we are also having the same thing, but instead of the correlation number we are having a plot. So between age and age, this is the graph. Okay, here you can see all the diagonal ones are exactly the same. Okay, but we do not want to take we don't want to take care about the center one. We want to take care about the distribution, overall distribution, how it is following. Okay, and if we are going through this particular distribution, which is between age and max HR. So from here you can analyze, it is starting from the top left and going towards the top right, which is exactly the graph here. But here it is max HR and age, just the reverse of it. Okay, max HR and age. Okay, or you can also take age versus, where is the max HR? Okay, that's the graph. This one and this one almost the same, no change. Okay, from here we can analyze another graphs as well. Like if I'm analyzing this, so in max HR and cholesterol, what is the correlation? Is there any correlation? Max HR and cholesterol, max HR and cholesterol, so they are having somewhat positive correlation. Okay, and max HR and cholesterol, if I am plotting the graph between max HR and cholesterol, and if I'm plotting a fit line, it will fit as well, because I'm having somewhat positive correlation. Obviously spelling mistake. So I need to write the correct spelling. And if I am fitting the regression line, this is how the line fits. It is not exactly how it should fit, because it is not fitting the best. It is not going for the best fit, but at least it's going through the origin. Okay, and the correlation that matters is almost 70 to 80%. If they are having minus 0.7
less than minus zero point 0.7 and more than 0.7 correlation is there, only that correlation matters. Rest of them are not that correlated. Like here you can see it is not exactly correlated, but we have find some of the correlation between this. Okay, so this is the pair plot. As I've told you, if you are having very large number of columns, then it might run out of the memory because it is plotting a lot of graph. It is doing a lot of competition. First of all, it is plotting the graph between age, then uh, age and resting BP, then age and cholesterol, then age and fasting BS. So it is doing all the combination. And if I'm calculating 1, 2, 3, 4, 5, 6, 7. So 7 cross 7 means it is plotting 49 graphs out of it. Okay, and it will help you to do the correlation. In this data set, the data set is not very much of correlated, through which so that we can drop some of the columns and take another one. But yes, this is very good to means train you how the things are working, how you can go for the pair plot, how we can go for the joint plot, how we can use violent plot. Okay, in which case which particular plot is best for you, how we can find the important insights of it, like we have find from this, we have found from this, like in this particular area there are more number of people who are not positive but they are tested, but here they are not there. But in this particular case obviously it is there, there are more number of negative, more number of positive. The average age of positive people are around 50, and negative people are around 50, positive people are around 55. Okay, these are some of the things that we have analyzed which is not actually given in the data set. We have found some important insights from it. So this is how you should perform EDA. We are also having some advanced aspects of it, which comes under exploratory data analysis, where we are fitting the bell curve if we are having less number of male or less number of positives, a more number of negatives, or if data is imbalanced, how we can deal with it. That is also something can be done, but we are not going to discuss it today or in this particular project. So that's pretty much it about this particular project, and I'll see you in the next one then.
So now we have discussed about what is the correlation between maximum heart rate and heart disease and other things. Okay, and from here we can actually plot a regression line, which will actually tell you if based on something we can analyze the output or not. For example, if we are talking about the heart disease, so as the maximum heart rate increases, okay, as the maximum age increases, maximum heart rate also decreases. This is the correlation that we have just found from the dataset, which is an important insight that we have gained from the dataset. You can also find more such insights from it. And yeah, that's pretty much it about from my side. If you're having any question, please let me know. Otherwise, I'll see you in the next video.